This video is on exercise 4H, exponential and logarithmic modelling using graphs. It's exercise 4H. Here's a first example. The population of wombats in Snubnose Gully is increasing according to the equation W equals 100e to the power of 0.03t, where W is the number of wombats and T is the years after the 1st of January 1998. Find the initial size of the population. So to find the initial size of the population, this is question A, we have to make T equal 0. So we insert that into the equation. So W equals 100 e to the 0.03 to the power of 0. 0.03 to the power times 0 is 0. So we get W equals 100 e to the power of 0. E to the power of 0 is 1. W equals 100 wombats. It's the answer to the first question. Must write wombats in. Part B, find the population 2 and 10 years after the number of wombats was first recorded. Give the answer to the nearest wombat. So for B, it's going to be W equals 100 e to the 0.03 times 2. Work that out on the calculator. And we get 106 wombats to the nearest wombat. So that's for 2 years there. For 10 years, W equals 100 e to the 0.03 times 10. And if you work that out, you get 135 wombats. So there we go. That's question B done. Next it says plot a graph of W against T. So here's the graph on the graphics calculator, TI Inspire. 100e to the 0.03x, used x in this case. So I had to choose my axes carefully here. It actually says in the textbook there, this example, to graph it for 0 to 30. So I've got 0 wombats here and 30 wombats over here. So I've graphed that exponential equation. There we go. Next question. Use the graph to find the size of the population after 15 years. Okay, so if we go to the next one, you can see there I've used a thing called trace on. And to show you how to get there, or to mention how to get there, if you've got a graph, you go to Menu, Points and Lines. So Menu, number 7, Points and Lines. And then select number 2, which is Point On. And then if you click on the graph and just trace along, you can find the Y value for any X value. So that's how I arrived at this here. I used that trace on and I've got 15,157. So the answer here will be 157 wombats. Next question, you can read it there. So we've got the population of a species of fish in Lake Underwater. And we've got this equation P equals A log T to the base E plus B. And we're given 2 points here. 1 week after the first dead fish was discovered, and T is defined as the number of weeks after the first dead fish was discovered. The population is 10,000. So we've got this point here, 1 and 10,000. And we've got another point here, the population was 8,000 after 5 weeks. Now we have to find the values of A and B, giving answers to 2 decimal places where appropriate. Let's place this first point into the equation and see what we get. And remembering that P is the equivalent of Y and T is the equivalent of X in this case. Okay, so 10,000 will equal A log 1 to the base E, because t equals 1, plus B. So I've just an extra 0 there. So 10,000 equals A log 1 to the base E plus B. So I've substituted those values in. So 10,000 equals, now we know that log 1 to the base E is 0. Okay, so A times 0 is 0. So that leaves us with just B. So that means B equals 10,000. We've established B straight away. Okay, so let's put in the other point now to find the value of A. So 8,000 equals A log 5 to the base E plus 10,000. Take the 10,000 across and we get negative 2,000 equals A log 5 to the base E. A equals negative 2,000 over log 5 to the base E. Okay, so if we work that out on our calculator, we get to two decimal places, negative 1242.67 as our value for A. Therefore our equation is P equals negative 1242.67 log t to the base E plus 10,000. That's our equation there for this situation for the population. Okay, so if we now look at the next question, C, find how long it would take the population to be 3,000. Okay, so let's have a look at our equation here. We'll just copy over to the next page here. There's our equation. And how long will it take the population to get to 3,000? So we'd substitute in 3,000 for P equals negative 1242.67 log t to the base E plus 10,000. Now we can put that in the calculator now, or we can fix it up a bit. We can take the 10,000 across and get negative 7,000 equals negative 1242.67 log t to the base E. We can go a bit further and we can go negative 7,000 on negative 1242.67 equals log t to the base E. And if we wanted to find out t here, the time, we would go e to the power of negative 7,000 over negative 1242.67. We can do that as well. Okay, so if we work that out, we get a value for t. And if we calculate that, we get 279 weeks. Okay, so next question. Question D here. I've added a couple of questions. Sketch a graph of P against T, clearly indicating asymptote. Okay, so I've put this graph in the calculator. You notice I've put the original version here, and when I've typed in the calculator, sometimes, depending on your calculator settings, can spit out this sort of version using exponential notation. Now remember that negative 1.24E3 means negative 1.24 multiplied by 10 to the power of 3. And sure enough, if you multiply negative 1.24 by 1,000, you end up getting something like that. So that's what the exponential notation means. Just get rid of that now. See, it's a log graph there. Now just remember a few things about log graphs. That normal log graph, remember, goes like that, and we've got a negative out the front here, so log graph will be that sort of shape there. Okay. Oops. So the asymptote, because we haven't got any left or right shift, you will see that we've got x there. It's not x minus anything or plus anything. The asymptote is still the y-axis, or x equals 0. So there's the graph there. Now the last question says, use the graph to find out how many fish there would be after 20 weeks. So same sort of thing again. There's my graph. I've set up the axes, which is really important, remember, with these graphs, to go between 0 and 30. And I know my highest number is going to be upwards of 10,000. Remember, after 1 week, it was 10,000, so I've gone up to 12,000 there, my y-axis, but the shape of the graph is important. And I've used that trace on again function to find out the answer. Now, it's given it once again in that notation like that. So to convert it, 6.28 e plus 3 means multiplied by 10 to the power of 3. Okay, that's what e plus 3 means. Same thing. Okay, so that's about 6,280, because 10 to the power of 3 is 1,000. 6.28 times 1,000, 6,280, and that would be the population there. Okay, I'd like you to go ahead now and have a go at exercise 4H. And that brings us to an end then of our work on exponential and logarithmic model using graphs.